Hey guys, welcome to another video. And today we're looking at power and efficiency, right? So power entails the rate at which work is done or energy is transformed from one form to another, right? So with power, we either can have work over time or energy divided by time, right? And those give us a unit of power to be equal to watt, right? So watt is another one which would be joules per second, right? But the SI unit that we use for power is watt. Now, let's look at an example. So if we have a man of mass 65 kilograms that walks up a staircase of each step being 16 centimeters and there are 25 steps, calculate the power he used to complete the staircase in 1.5 minutes, right? So the first thing I normally do with questions in physics is to actually write down what we're given, right? So, or we can just underline to get all factors or variables known, right? So we know the mass, which is 65 kilograms, right? We have the height of one step, which is 16 centimeters. We have the number of steps being 25, and we have the time, which is 1.5 minutes, right? So another thing that I find most students do is ignore the units, right? So all they'll do is just use the numbers given to calculate, right? But an important part of physics is actually getting all your quantities in their SI units, right? So before we do any form of equation and calculations, we ensure that we convert our units to SI units. So for one, we need to convert 16 centimeters to its SI unit, which is meters, right? So 16 centimeters to meters, we divide by 100, we get 0.16, right? And then we have time here in minutes, right? So our SI unit for time is seconds, so we would multiply 1.5 times 60, right? So our height of our staircase would be in meters, the 0.16. Because we have 25 steps, we multiply by 25 to get the height of the entire staircase to be 4 meters, right? And the time, 1.6 times 60, give us 90 seconds, right? Now, we need to find what the power is, right? Now, because we're given the mass is going up a height, right? So that means when he reaches the top of the staircase, he's going to attain a potential difference, or sorry, a potential energy, right? So because he has potential energy, we can use that as the energy that he used, right? So remember, conservation of energy is kinetic energy reaches, once he reaches at the top, he's going to stop, right? So all that energy is converted to potential energy. And we know potential energy from our last lesson is mgh, where m is his mass, 65, g is 10, right? And h is the height that he would travel, which is 4 meters above the ground, right? So we get 2,600 joule of energy that he used, right? So we know power is equal to energy over time. So the energy is 2,600 over the time in seconds, which is 90. So we get power equal 28.89 watt, right? So that's very important, guys, that you convert your units to their base or SI units before doing any calculations using your equations, right? So the next part of the lesson is about efficiency. Now, efficiency tells us how effective work is being done or energy is being transformed to another form, right? So we normally hear efficiency when it talks about machines. So machines are 50% efficient, 88% efficient, 90% efficient, right? And what that tells us is how effective these machines will actually do what it's supposed to do, right? Given what the energy or the power or the work that you're going to put in, right? So that's what efficiency is. So therefore, we have 3 equations for efficiency, which is the work output by the machine or by whatever is going to do the work over the work input, right? So we're putting in the work what work will be produced out, and times by 100, right? Or energy output. Now that energy output is the useful energy, right? Because remember, we have heat energy that can be produced, and that's not useful energy in our machine. So therefore, it's only the useful output energy over the input, right? Times 100, and final one is power output over power input times 100. And because each case is multiplied by 100, then our unit for efficiency is percentage, right? So let's look at this example. So if we have a 60-watt bulb, which runs for 12 hours and loses 300,000 joule of energy as heat, calculate its efficiency, right? So again, we identify what we are given. We're given the power, 60 watt. We're given that it loses 300,000 joule, right? And the time is 12 hours, right? So again, we look and we see that time there is not in its base unit. So therefore, we have to convert the time from hours to seconds, right? So remember, from hour to minute is 60, from minute to second is 60, so that's 60 times 60 to move from hour to seconds. So therefore, it's 12 times 60 times 60, we get 43,200 seconds. That's in 12 hours, right? So now that we have time, right, and we have power, right, we can find the energy that is being inputted into the bulb. And energy in is the power times time. Power is the 60 times the time, 43,200, and we get 2.59 times 10 to the 6 joule. So this is the amount of energy that is being supplied to your bulb, right? Now the output voltage, the output energy would be, right, this energy minus or waste, right? So remember, the output is actually your useful energy. So it's what is there minus what is used as a waste, right? So as a waste is 300,000, and we minus that, so we get 2.29 times 10 to the 6, right? And we put it over what is input energy is, which is 2.59 times 10 to the 6, also multiply by 100, and we get this bulb to be 88% efficient. And what that tells us is that this bulb will actually use 88% of the energy being supplied to it to convert it to light, right? Because the purpose of a bulb is to create light, right? So everything, that 12% that is lost is actually would be not useful in the purpose that you want it for, right? So in a case that you want majority of light and less heat, then you'll consider if that is a good enough efficiency for your purpose, right? But let's say you wanted a light that creates a lot of heat, right? Then that means you look for a bulb that will give you less efficiency. That means that it gives you less light but more heat, right? So efficiency in our life is very important because it's able to tell us something about the product before we actually buy it, right? So thank you very much, guys, for watching today. Hope you understand about power and efficiency, right? And see you guys next time.